Hi everyone, and welcome to another video from Erik's Electronics Workbench. So on the bench today I have the Spectro Acoustics Model 210 stereo audio equalizer. This is a piece of vintage audio equipment from the 1970s. So the story with this equalizer is that the owner tried to power it up after it had been in storage for many years, and upon connecting it to his stereo system found that it made an absolutely horrible sound out of the speakers. In fact, it was so bad that he thought he had damaged the speakers. So it's on the bench here for repairs. So let's get started with the troubleshooting and see exactly what's going on with this equalizer. So the owner of this equalizer purchased it new in the 1970s, and it's in very nice cosmetic condition, so it looks like it was well taken care of over the years. Now he also included the owner's manual, and a couple pages in here, it looks like in the front right here, you can see the original purchase date was filled out, so 8/4 of 77. Now unfortunately in this manual there's no schematic, but I did find the schematic online, so I've printed that out. That should be helpful for troubleshooting, and we can look at that a little bit later. So let's take a quick look at the front panel layout and also the back panel connectors. So you can see this says channel A and channel B, but of course on a stereo setup this is the left channel, that's the right channel, and of course it does say left and right down there as well. So the unity gain adjustment, let's say you've boosted up some of the frequencies and then the output of that channel is a little bit louder than you want. You can cut the gain down just a little bit, or if you've cut some frequencies then you can boost the overall gain, and it just helps to match things, so each channel has a gain adjustment. So there's an LED right here for the power indicator, and that's of course the main power switch. EQ bypass, that switch is just taking the input and going right to the output, just bypassing EQ settings. EQ on the line is of course the normal mode, it's just applying the equalization to the output. EQ the tape is putting the equalization settings on the tape for recording a pre-equalized tape. And tape monitor or source, just depending on what you want to monitor. So let me turn this around here, we can take a quick look at the back panel. Zoomed in a little bit closer here. So it had the gyrographic equalizer. So of course an unswitched outlet right here, so that's just an auxiliary type outlet, 500 watt maximum. And then over here the RCA connectors for the inputs and outputs. So again it says A and B, but also left and right. Now I'm noticing that these RCA connectors, very nice quality. They have a mounting nut and then an insulator, so these are insulated from the chassis. They're not using the chassis as a ground connection, so there must be a separate ground wire for all of this, and the ground in here I imagine is floating and probably not connected to the chassis, and even if it is, for whatever reason they've isolated these off of the chassis, so very nice quality. Alright, so the next thing that I'll do is remove all of the hardware, the screws that are holding the cover on. I won't bore you with doing that. Let's take a look on the inside, and if everything looks okay, I don't see any obvious damage or anything like that, then we'll go ahead and power it up, and I'll connect the output to my oscilloscope, I'll put an audio signal in, and let's verify this noise issue that the equalizer was having. Let's see if we can verify that, and we'll start in on the troubleshooting. Okay, I have the top cover removed from the equalizer, and at first glance everything looks okay, so I don't see any problem with powering it up just for an initial test. All the wiring looks to be in good condition, looks original. The two electrolytic capacitors for the power supply section are not leaking or bulged. Now, they probably need to be replaced given the age of the unit, but for an initial test I don't see any problem with them. Power transformer looks perfectly fine, no signs of overheating or anything like that. There is a fuse, and I already tested it, and it's not blown, so no problem there. Now, the AC line comes in to this convenience outlet, and it's just connected right across the back of the outlet. There's absolutely no insulation on those connections. So if you're following along, you're absolutely doing so at your own risk. Always use an isolation transformer to power up a device like this. And remember, an isolation transformer does not protect shock against the line, but it does prevent shock from contacting the hot AC line to ground. So again, always use an isolation transformer for testing. And if you're following along, you're doing so at your own risk. Know the safety precautions, take care, and be safe. Now there's an Easter egg in here I want to show you real quick before we continue on with the troubleshooting. Turn this like so, and let me get you zoomed in here. Look what they put on the circuit board right here. Check that out. So you can see, they actually cut out this hole so you can see the trace on the board, and get that a little bit closer there. See the little character down in there? So that's Kilroy. So the little guy with his nose looking over there and his little hands to the side. And that looks like a trace on the board that's part of some circuit that's in there, and his nose and his head makes part of the trace. So in fact it looks like the trace above it bumps up and over his head. So funny little Easter egg that they included in there. And there's actually something else on the bottom down here. You can see it's actually upside down, but it says Little Diablo or Little Devil. So I'm not sure why that sticker is in there. Maybe an inspector that looked at it, or it was some internal code that they had. I'm not really sure. If you have one of these equalizers and it has a tag in there that says the same thing or says something different, please leave that in the comments. I'd be curious about that. So I will continue on with getting this connected to my oscilloscope and the signal generator, and let's check out the fault condition, just verify how it's actually performing, and then we'll continue with the troubleshooting. Alright, let's make the connections from the equalizer to the test equipment. So I'll start on channel A. All the frequency sliders are at their midpoint, so there's no cut or boost on any particular frequency. Unity gain will stay at 0. And I'll leave this on EQ bypass, so the signal should go from the signal generator through this with no adjustments, and when it appears at the oscilloscope and everything looks okay, then I'll switch this over to EQ line and I'll turn the power on. Now these cables that I'm using, just a 50 ohm coax cable, perfectly fine to use a cable like this at audio frequencies, no issue whatsoever with that. But one end has this BNC connector, so that goes to the test equipment, and then the other end of the cable has an RCA connector, so you don't have to use any adapters. That way everything's done in one cable, so very handy to have cables like this. So let me get you positioned up to the signal generator first. Pardon the camera movement. Alright, so the signal generator is set to a 1 kilohertz sine wave output at 300 millivolts RMS. Grab the coax cable here, plug this in, like so, and I'll turn the output on in just a moment. Alright, let me put you over on the oscilloscope. Alright, so the output of the equalizer can go here on channel 1, and I'll switch on the signal generator. Alright, there we do have a signal, and put you over here. It's the time base a little bit faster. So we can see signal is 298 millivolts, so very reasonable because it's set to 300 millivolts on the signal generator. And it looks like a 1 kilohertz, so exactly what we expect. No problem there. So now I will come down here and switch on to EQ line. So, yep, that goes away. Now let me turn the power on. Whoa, that looks a little bit unusual. So let's see what's going on here. So that should be a sine wave, but it looks like that is something entirely different than a sine wave at a very different frequency as well. Let me switch off the signal generator. Wow. So that actually looks like maybe an oscillation is happening in the circuit. So go back over here. Yeah, look at that. Very interesting. So right now the signal generator is turned off. So I'll turn the power back off on the equalizer. Yeah, it goes away. So the ground reference is right through the center graticule. So that's where the trace is when there's no input. So it looks like a very slight offset there. It's creeping back up to the ground reference. But I'll turn the power back on again on the equalizer. Yeah, look at that. There's definitely some kind of an oscillation happening. So you can see the amplitude is about 1 volt RMS. And look at the frequency. It's kind of hunting around between 13 and maybe as high as 16 kilohertz, but most of the time it's about 13.7 kilohertz. So I can see why this would make a horrible sound if you connected this into an audio system, because this would basically be putting out a very strong 13 kilohertz signal that would be going out, into the rest of the audio chain. So clearly something wrong. It looks like an oscillation happening. That's definitely not hum like you would get from a power supply, maybe like a bad filter capacitor. I can't see that happening because that would be a much different frequency. So this is a very, very high frequency. It definitely looks like an oscillation. So let's go to the other channel. Let me move the connections around, and let's see if the other channel is working normally or if it has a problem as well. Alright, I have the connections moved over to the channel B, or the right channel on the equalizer, so let's see if that channel has any issues or if it's functioning correctly. Also, pardon the flickering that you see up here. That's not something that I can see. It's just the camera not playing nice with the refresh rate on the CRT. Okay, so I'll turn on the signal generator. Alright, and of course the equalizer is in the bypass setting and its power is turned off, so we can see there's a little bit of a trace there, but let me slow down this time base. Go too far there. So 1 kilohertz at about 298 millivolts RMS, just shy of 300 millivolts, which is what the signal generator is set to, so makes sense. No problems with that. So now let me go over to the EQ line position, and I will turn on the equalizer now. There we go. So that channel is actually looking okay. I don't see any major problems so far. Let me give some boost to that output. Yep, that works. And the unity gain cut down there is attenuating the signal. So no problem with that. That's looking okay. So at 1 kilohertz, 960 hertz or 1.92 kilohertz would be the two sliders that are kind of right around that frequency. So if I take the 960 hertz slider and move it up, so definitely some noise there, that's for sure, but it does boost or cut that frequency. So the sliders are going to need some attention. They're definitely kind of scratchy and noisy. So the 1.92 kilohertz or 1920 hertz slider, if I move that up, down, so it has some effect as well, so no problem there. So let's just go down. So the first slider is 30 hertz, so let me change the frequency to 30 hertz. Go all the way down here like so. So if I take the 30 hertz slider and go up, yeah, again there's some noise there, but it is working. It cuts down, goes all the way up, so no problem with that. And then the highest frequency adjustment is 15.36 kilohertz. So over here, frequency 536. All right, and all right. So there he confirms the frequency and gives some adjustment, goes up there, gives some boost or cut to that frequency, no problem with that. So it looks like the frequency response on the channel B, or right channel, is working okay. I really don't see any problems there. Other than some noisy adjustments and controls, that channel is probably functioning correctly. Slider is working very well for the overall gain on that output. Yeah, so it looks like the problem is just going to be on the left channel. So let me start to disassemble the equalizer a little bit further so we can get into that circuit board that's really behind the front panel. It looks like that's where all the electronics are, and see exactly what's going on. I don't think this is a power supply issue, but we'll check the power supply voltages first and then move into the circuit. So I'll continue on with some disassembly, and when I have some updates, we'll continue on and I'll show you. Okay, I removed all the knobs and there are 4 screws, and then that allowed that front panel to be taken out of the way, so that it gives access to all the components on the main circuit board. So let's start by measuring the power supply rails. So there's a positive 16 and a negative 16 volts that's distributed to all the op amps in the equalizer. Now all the op amps are the same. They're all a type 4136. And on the 4136, pin 7 is the negative supply and pin 11 is the positive supply. So if I come over here with the probe, the center tap on the transformer, which is the ground reference for the power supply, comes over to this trace on the board, so I can just probe against the side of this capacitor on this lead right here. And if we look at this op amp as an example, there's a little dot right there on the package. So this is pin 1, down to pin 7, across is pin 8, and then up to the top is pin 14. So let me get you zoomed in a little bit closer. You can see a little better what I'm doing here. So again, pin 7 right here should be the negative rail, and it is, negative 16, looks perfectly fine. And then 8, 9, 10, and 11 right here. There it is. Positive 16 volts, no issues with that. So the voltages look perfectly fine. Now something that I noticed is that this LED right here looks quite dim. You can barely see it glowing. Now I personally don't like a blindingly bright LED on a piece of equipment like this, but this is very, very dim, so I think that could be improved on. I'm not sure why that LED looks so dim. It may have just aged or has gotten weak. If we take a voltage reading across the LED, about 0.56 volts. So I'll try replacing that LED and see if I can make that just a little bit brighter. But that really has nothing to do with the troubleshooting right now, so we'll get back to that a little bit later on. Now something that I did notice in the power supply section, take a look at the schematic real quick here. I think they made a revision at some point, but you can see here, this shows 2 Zener diodes right here, so the positive rail and the negative rail, so these are probably 16 volt Zener diodes, or maybe 15 volts, something like that, right around in that range. And you can see there's a series resistor right here, so this is basically just pulling this side of the resistor and holding it at that regulated voltage, which should be about 16 volts. So a very simple voltage regulator. Same thing is going on down here. But again, there's two Zener diodes shown, but on the circuit board here, there is only one Zener diode, and I'll get you zoomed in a little bit closer yet so you can see. Move this up just a little bit here. So, point to it right here, but down right there is a Zener diode. Actually, you can't quite see it there. Right there. So there's only one Zener diode in here, and if I measure across it, back out again here, you can see the voltmeter. If I go across that Zener diode like so, you can see we're getting 32 volts, which of course makes sense because we have two 16-volt rails. So I think what they did is they modified this, and instead of using the two Zener diodes, they just have one Zener across here for the regulation. So I'm thinking this may be a newer design. They probably figured out a way that they could save a little bit by eliminating an extra component. So my guess is that this was done after the schematic was designed. Probably the schematic was the original way. But nonetheless, the power supply is working perfectly fine, so we can move on to the issue with the oscillations. So something else on the schematic. So if we take a look here, none of the components are actually labeled with the values, which is unfortunate. They did mention the type of op-amp that's used in here, but all the capacitors and resistors don't actually have the values. So of course you can look on here and, you know, the colored bands and the markings on the capacitors and so forth. But unfortunately they didn't mark them on the schematic. And also the schematic has component locations, like it says, you know, capacitor numbers and so forth on here and resistor numbers. But on the circuit board there's no silk screen. There's no actual references to any components. So I'm thinking there must have been a service manual. Maybe they had drawings that called all of that out, but it's unfortunate that they didn't mention any of the markings on the circuit board or have any of that called out. So it makes it a little bit difficult when you look at here and you know, they reference different op amps and the different components and things on here, and then you look at the circuit board, you really have no idea where that's at without studying the circuit and kind of tracing things around a little bit. So if I take a look over here, let me move the camera over to this side a little bit. So this is the side with the problem, and I believe this op-amp right here is sharing double duty. Some of the, there's of course 4 op-amps in the package. 2 of the op-amps go up here to the frequency adjustments, the filters, but 2 of the op-amps are used in this stage right here, where you have the input op-amp and the output. So basically the signal flows that the audio is coming in here, it goes into this input op-amp, input amplifier, and then you can see that the signal comes down into these filters. So these are bandpass filters at the different frequencies, and then the signal is returned back up here to the output amplifier and then makes its way to the output connector. So I believe this is the op-amp that is doing that. This op-amp has all of its connections going up here to these sliders, and so does this op-amp. All of the connections go up to these sliders here, and of course you can see the same thing that's done on the other channel. And looking at one other thing on the schematic, they mentioned that this is drawn for the left channel, which is the channel that we're concerned with. But there's a note down here that on the right channel, the output op-amp has basically a mirror image. It's flipped around on the which op-amp within the package is doing which function compared to how they're set up here. So just a note, so when you're probing around on the different pins, it's important to make note of that. So let me put you back up on the oscilloscope, and I'm going to probe on this output op-amp on this pin right here, which is pin 10 and then pin 12. Let's look at the signal on each of those pins and see exactly what we have. So let me move you back up here to the oscilloscope. Okay, that's the signal at pin 10, so that's the output of the input stage amplifier. So we are seeing something there, which shouldn't be any signal. So a little bit of noise from that oscillation. And then let's go to pin 12. So that's pin 12, yeah, there's a very large signal there, which makes sense because that's the output going to the back panel connector. So again, looking at the schematic, it looks like we're seeing a little bit of a signal right there and then a very large signal over there. Now I'm wondering if there's a problem happening down in this area here, or perhaps this stage right here is oscillating just a little bit and then it's being amplified tremendously over here. If there was a lot of oscillation happening down here for some reason, perhaps a little bit of that is making its way and just being detected here because there's just this resistor, and maybe it's just picking it up there. So let me get back over here. If I go to pin 12, oh yeah, look at that. So on the output, pin 12, if I move any of the sliders, it has a huge effect on the oscillations. Yeah, look at that. It changes drastically. Really on almost any of them it has some effect, but definitely on the higher frequencies. So I tried using my noise detecting probe to find where the problem was in the circuit, and I've had good luck with this probe in the past. In fact, I demonstrated it on an ADCOM amplifier that I was doing a repair on. So you bring the tip of the probe up next to the component, and when you get near the noisy transistor or a noisy resistor or something like that, the speaker emits crackles and pops and other noises, and then you know where the problem is at. So it works very well for that. But in this circuit, the noise is pretty much present everywhere because it's just going through all of the components, and it's very, very high-pitched frequency. It's near what, 14 kilohertz, or what we were seeing, 16 kilohertz, something like that on the oscilloscope. So I was able to hear it, but it's not easy to hear with this speaker. It's just a very, very high-pitched kind of a whining sound. I don't think it would even pick it up on the camera, but I really couldn't narrow it down anyways because it was present, in numerous areas in here. However, I think the probe inadvertently did find where the problem is at, but not in a way that I expected. So of course this probe tip is insulated, and you can come right up and touch the components. And in doing so, I got over to this op amp right here and just touched against it, and all of a sudden I noticed the kind of whining, high-pitched sound stopped. So of course I was bumping, right up against it. And I thought, well, that's interesting. The oscillations, I think they're gone. So I checked with the oscilloscope, and sure enough, the circuit was quiet. So then I started looking closer at this op amp and realized that I think the problem, in fact, you can kind of see it right there, how it's rocking around in that socket. So let me kind of just zoom in a little bit closer there. Let's see how the op amp is kind of just wiggling back and forth right there. I wouldn't describe it as extremely loose, it's just that it can wiggle in the socket. It doesn't just fall out if you try and pull up on it, but I'm not sure if the socket is defective, or if, maybe we can get that to tighten up a little bit there. Maybe I can bend the leads out on that device a little bit. I'll certainly take it out and try and clean it. Maybe there's just a little bit of oxidation or some corrosion on the leads, or maybe down in the socket, insert it and remove it a couple times. But it really seems like this is where the problem is at. I think what I'll do is just remove all of these op amps and just clean all of them, put some contact cleaner down in the sockets, and install and remove the components. But let me put you back up on the oscilloscope, and I'll probe on the output of this amplifier while I move this chip and take a look at the effect that it has. Alright, I had the oscilloscope probe on pin 12 of the output stage, and I'll wiggle out around this other op amp and look at that with the noise that happens right there. Now I'm not even touching it, and it started that oscillation again. And then if I wiggle it just a little bit, now it completely goes away. Comes back again. It's very sensitive. Don't have to move it too much at all now. Yeah, kind of push it into the socket a little bit further. Yeah, no, came back. Now it went away on its own. But yeah, that's definitely the problem. I'm not really seeing that happen. Oh, I am seeing it. I take that back. This other op amp, I wiggled it there, and it came and went a little bit as well. So I think all of these op amps need to be removed, cleaned up a little bit, and if necessary, the sockets can be replaced. But this one is definitely very sensitive over there. But I think all of them really are needing some attention. And this one over here is not nearly as sensitive, but it did seem to have, a little noise right there. You can see that in the middle of the oscilloscope. Just a little bit of noise. So let me take a closer look at all of those op amps and the sockets, and I'll be back and I'll let you know exactly what I've decided to do. Alright, the new components have arrived, so the various electrolytic capacitors and the sockets for the op amps. So I'm going to replace all of the op amp sockets because I tried cleaning this socket with contact cleaner, and it didn't seem to improve it at all. So I think what's happened is that the contacts have lost the spring tension down in the socket. It's just not squeezing the pins on the integrated circuit the way that it's supposed to, or there's some tarnish that is just really stubborn and is not coming out, coming clean. But I think more than that, it's just lost the tension that the sockets are supposed to have. So replacing all 6 sockets really is the only way to make this more reliable and get rid of the problem that we're seeing on it. Now, as usual with the capacitor replacements, go with a high quality brand, go with a trusted vendor. These are all from Mouser Electronics. These are Vishay and Illinois capacitor, so very high quality. And when you're replacing capacitors, make sure to go with the equal or higher voltage rating, and don't change the capacitance value unless you know what it's going to do in the circuit. So of course these are all identical to what was in here, except I believe these have a little bit higher voltage rating, the others are identical. A little bit smaller size than the originals, and that's just modern technology. So they'll easily fit on the circuit board. But make sure to take measurements and make sure that the new components are going to fit where you expect them to go on the board. All of these are axial type capacitors, they're not the radial lead capacitors. Now, to desolder the components, all of them are across this bottom portion of the board down here, and this metal bracket that you can see, that's kind of a shield right here, it wraps around the board. It stops right here, and kind of see down in there, you can see the part of the circuit board right there. So all of the components are in this area down here, so I shouldn't have to remove this to have access to the back of the board. But you can see my desoldering tool right here is not going to fit in here. There's just no way to reach down in there. So what I'm going to have to do is remove this whole assembly from the chassis. So there's some screws down here, but there's also a couple little jumper wires that looks like some ground wires that are just linking from various ground connections and so on. So I'll desolder those as well, and then I'll be able to move this. I don't think I need to remove any other wiring back here, but if necessary I can desolder that as well. But I think it can just lay forward, and then I'll have access to the back of the board. So these two electrolytics back here, oddly this one has the negative arrows right here, and let me get you zoomed in just a little bit closer too so you can see what I'm talking about here. So you can see these arrows right here that are pointing. So this is the negative, and they have a little negative symbol inside in the center of the arrow. So that's very common. You often do see that on a capacitor. But the one right next to it, these are both exactly the same rating, 25 volt, 470 microfarad, but this one has arrows with a positive mark inside of them. And oddly, they're also pointing the same direction. So they're pointing across to this, but this is the positive, this is the negative. So if you saw those arrows and you just assumed that, both were pointing to the negative and didn't take, a special note on that, very bad things would happen when you install the new capacitors if they're in backwards. They'll basically explode. So what I'm going to do on the board, because there's no silk screen on this board, I'm going to mark a couple different things before I remove any components. So on all of the integrated circuits, I'm going to put a little black dot by pin number 1 so that they're oriented correctly, because again, there's no marking on the board. And on all of the capacitors, I'll mark the negative side with a little black dot on the circuit board, just a Sharpie pen. And again, that'll confirm that everything is installed correctly. So I'll get started on all of that, and I'll be back when I have some updates. So I decided to remove this board from the wiring because as I would be working on the board, I'm turning it back and forth to have access on both sides, so it's just easier not to have it tied in with all of these wires. So at this point, all the electrolytic capacitors have been replaced. The 6 op-amp sockets are all changed out. I've cleaned all of these sliders, so they're potentiometers basically, and I just worked some cleaner down into the slots and activated them a number of times. So for the cleaner, I use this product. Works very, very well. I also put some contact cleaner into these switches and activated them a number of times. I replaced this LED, so as you recall I mentioned it was very dim. I found a suitable replacement, same size, fits in the hole that's in the front panel. You have to form the leads very carefully so that it pokes right through the front panel. So I put the panel back in place and then bent the leads the way the original one was installed. So I was able to test it on here without having this installed because this LED gets its power from the secondary of the transformer through a resistor and a diode all contained on this circuit board. So that's in good order now, very easy to see, so it looks very nice. Now I noticed on several of these op-amp integrated circuits, some of the leads were very, very tarnished. I tried to clean them the best that I could, so I've put them all back, but I don't like the chances of reliability with the way some of them looked. So I think what I'm going to do is order up some new op-amps and get them replaced as well. So I'll continue with the reassembly, and when everything's back together, we'll power it up and see how it's working. So the new old stock op-amps have arrived, so I replaced 2 of them on the left channel and 2 of them on the right channel, and everything's powered up, and you can see there's an output on both channels, noise-free, looks very stable. So we'll do a more thorough test on the equalizer in just a moment. But these are the 4 op amps that I replaced, and you can see, interestingly, this one here looks like it was made by Texas Instruments and the others are made by Fairchild. So the Texas Instruments has a 76 date code and the others are all date coded 77. Now the replacements that I found are made by Fairchild and they're date coded 81. So let me show you just as an example. All of the op amps that I replaced have the same problem, and that is that the leads are really tarnished and the plating has basically come off. So I don't know if this will pick up very well on the camera or not, but you might be able to see some of the plating is gone. And although I've tried to clean them, I'm sure that they'll just tarnish again because that original plating is just non-existent on many of the leads. So getting those replaced was definitely a necessity. So it looks like it's working well enough to continue on with reassembly, so I'll get the front panel put back on, all of the knobs, and then let's run through a test and check all of the different sliders, the different frequency ranges, and make sure that everything looks like it's working correctly. So I'll get that set up next. So before I reinstalled the front panel, I cleaned it, and I also cleaned all of the knobs. So the white line that's on each knob is actually painted into a recessed area, so I just spent some time cleaning that recessed portion of any grit and grime that had built up, and also cleaned the back side of each knob. So I think the front panel has a nice, bright, crisp look to it, and turned out very nicely. So the final thing I need to do is to test the equalizer and make sure it's functioning correctly. So I have my signal generator connected on these 2 cables right here going into the equalizer, and the signal generator is set to 300 millivolts RMS output, and I'll tell you the different frequencies that I select as we go through the tests. And then the output from the equalizer is going over to the Fluke 199C scope meter. So you can see the left channel right there is connected to channel A, which is the red trace on the scope, and then the right channel right there is connected to channel B, which is the blue trace on the scope. So the first test that we need to do is to make sure that the equalizer has a flat frequency response from 20 Hz to 20 kilohertz. So all the frequency sliders are at 0, and the unity gain controls are also at 0, and then it's on the EQ line position. Of course, power is turned on. So I'll reach up here and turn the signal generator on. So we have some output here. Let's make a few adjustments over here on the scope. So let's bring that down there, bring that one down, slow the time base down here a little bit, sweep time. Okay, so we can see we have 291 millivolts RMS on channel A and 290 millivolts RMS on channel B. So those voltage readings are right up there on the top of the screen. So both channels look really closely balanced. That's a very good thing to see. Now, of course, if you just nudge one of these adjustments just slightly, of course, those values would change. So I have it lined up, very, very close on the markings that are just on the front panel. So looking very good at this point. So again, that's at 20 Hertz. Now I'll go up to 20 kilohertz. So let's try that. All right, there's 20 kilohertz. And speed this up here. All right, 286 millivolts on the channel A and 286 on channel B, 287 right there. So looking very balanced between the channels, just ever so slightly less than we saw at the lower frequency, but really not that far off, no issues with that. And let's try the standard frequency at 1 kilohertz. A lot of tests on audio equipment are performed at 1 kilohertz. Let's try that frequency as well. So 1 kilohertz right there. Slow the sweep time down, and we have 298 millivolts on A and 295 on B. Again, looks very good, no problems there. So the frequency response through the equalizer is looking really flat, no issues with that, so that's very good to see. So now I'll go through the frequencies that are marked on each of the frequency adjustments. So we have 30 Hertz all the way up here to 15.36 kilohertz, or 15,360 Hertz if you like. And we'll just work on one frequency at a time, and I'll boost it all the way up, and let's make sure that both channels have the same amount of gain on each of those frequencies. So I'll change this back here to 30 Hertz to start with. Okay, there's 30 Hertz. So I'm going to slow the sweep time down again, right there. And let's boost 30 Hertz all the way up. We're going to have to make a quick adjustment here. Let's try that. Okay, so 1.37, spot on both channels, no problem with that. So the outputs are balanced, look very good. So now I'll go to 60 Hertz. Okay, there's 60 hertz. Now what I need to do is bring this slider down, go back up on that one, bring this one down very close to 0 mark right there. Let's go up on 60. All right, 1.22, 1.24, so very, very close in levels on each channel. Okay, let's go to 120 hertz. So put that down, go up there, go down to 0 here, to 120 there. So we have 1.13, 1.21, so very, very close in levels there. So let's go to 240 hertz. So again, bring this slider down, go up on 240, down there, go up to 240 like so. Speed the time base up a little bit there, sweep time. So we have 1.19 and 1.22 for the amplitude. And that's in RMS volts. So very close between the channels and looking very, very close to some of the previous readings that we saw. All right, let's go to 480 hertz. All right, there's 480. So up like that, down, go up to 480. 1.16 volts RMS and 1.16 volts on the other channel as well, 1.17, so basically identical and looking very, very close to previous values, so looks perfectly fine. All right, let's go to 960 hertz. So 1.18 volts on the left channel and 1.2 volts on the right channel, so no problems there. So the next frequency is 1920 hertz or 1.92 kilohertz. And that looks very good as well, 1.14 volts and 1.18. And so the next frequency is 3.84 kilohertz. So 1.16 volts RMS on both channels, spot on. That looks perfect, no problem with that. So all these values that we're seeing as we're working through these frequencies are looking very close when the amplitude, when this is boosted all the way up for the individual frequencies, the output on both channels is looking not only balanced between the channels, but it's at the same value as it was on the previous frequencies. So it really looks like the equalizer is performing very, very well. So the next frequency is 7.68 kilohertz. All right, there's 7.68 kilohertz on the signal generator. Bring that back down, go up there, go up like so. Speed the sweep time up there. All right, so we have 1.24 volts and 1.22 volts. So that looks perfectly fine, no issues with that. And the final frequency is 15.36 kilohertz. All right, there's 15.36 on the signal generator, 15.36 kilohertz, and like so. Speed that up a little bit there. So we have 1.29 and 1.25, so very, very close in value between the channels, and again, very close to the previous values that we saw on the other frequencies. So this equalizer is definitely performing very well. No issues whatsoever with it. All of the noise problems, all of the oscillations are gone. The output is looking very, very stable. If I turn the signal generator off, you can see the output is noise-free and just sits there, you know, exactly at 0 volts. No problem with that. So the last thing to check is that the equalizer is supposed to be able to output up to 10 volts RMS. So let's make sure that it can do that. So I'll go to 1 kilohertz on each input, and then let's see if we can boost the unity gain controls up and maybe even drive the input just a little bit higher if necessary, and see if it can achieve an undistorted output up to 10 volts. So first of all, reach over here. I'm just going to set these back down, so like so. And we will go to 1 kilohertz. Alright, signal generator is turned on. Slow the sweep time down. And put that on a different range there. Let's boost that all the way up. And we'll go to 960. We'll give that some gain right there. Probably going to need to adjust both of those like so. Alright, so that looks very good right there. So the signal generator is actually set to 600 millivolts RMS, and we can see the output is at 10.6 volts on the left channel and 10.2 volts on the right channel, so very, very close in value. And let's take a closer look here, speed that up a little bit. The waveform, not really seeing any issue. There might be just a slight amount of clipping right there at the bottom of that waveform, and the top it looks like they're just starting to clip just a little bit. Let's lower this down just a slight amount here. Yeah, it looks like it does clean up that waveform. I think that was clipping just a little bit. It looked like the bottom of that waveform had a little flatness to it. So that's 530 millivolts RMS input. And we're seeing 9.7, 9.1 volts, so very close to the 10 volt value, just slightly under. In a normal application, you really wouldn't be driving this to 10 volts on a typical audio system. The voltage levels don't typically rise that high. They're typically down in the millivolt range, 150 millivolts, 300 millivolts. Those are typical values that you would be seeing on the RCA type cables that you're interconnecting audio equipment with, tape monitor loops and so forth. So seeing it, up to 9 volts or so like that is really well above anything that you would expect this to actually drive, in real application. So really no issues with that whatsoever either. Looks like it's functioning perfectly well. So the Spectro Acoustics Model 210 equalizer is functioning very well, and all the repairs are complete at this point. So the owner of this equalizer will be able to get many more years of trouble-free use out of this equalizer in his audio system. So if you enjoyed this video, don't forget to give it a thumbs up, and if you're enjoying the videos on this channel, please remember to subscribe. There'll be many more videos coming up in the near future, all things electronics, all types of repairs, troubleshooting, test equipment, audio equipment, vintage, modern, so you won't want to miss any of that. So definitely subscribe, and hit the bell symbol to be notified when I post a new video. So as always, thanks for watching, and until next time, take care, and goodbye for now.